It would be one of the most complex machines ever built. It would take 10,000 people and nearly 5 years to build it. It would cost an estimated $5 billion. Success was anything but certain. The plane would contain more than 4 million parts supplied by contractors around the world. But would they arrive on time?
Miss your first commitment and then things start to go wrong.
And would they work?
From a technical point of view, I would not put this back on the airplane if I had a choice.
Nothing could be left to chance.
154.
This would be the most tested airliner in aviation history. Eventually, lives would be at stake.
There's an apprehension anytime you change technology.
To make it all work, the company would reinvent itself from the inside out. And all of this would have to happen at a time when the world's airline industry was in recession. If the 777 were to fail, the company's future was at risk. Success would keep Boeing ahead of the competition for decades to come.
1, 2, 3.
This plane would be built to set a new standard for commercial aviation. This is the story of the building of a 21st century jet. In the northwestern United States, a group of engineers was about to monitor the first flight of Boeing's newest airliner. There was a lot at stake. Boeing hoped that this plane, the 777, would assure the success of the company into the 21st century. It had taken 10,000 people nearly 4 years to design and build the plane, using the latest technology, including 2 of the largest engines on any airliner in the world. But the plane had never left the ground. John Cashman, the chief test pilot, would take the 777 into the air for the first time if all went well.
Okay, ladies and gentlemen, it is now your cue to move back behind the barricade so the airplane can taxi northbound. Please move forward.
First flights are always risky. There are only 2 people on board, the pilots, who both carry parachutes. On the ground, all the chief engineers were on hand to help if the plane developed problems with any of its systems or structures. Among the people with the most at stake were Phil Condit, president of the Boeing company, and Alan Mulally, leader of the engineering team, who had lived and breathed the plane for more than 5 years.
Okay, ground, you can disconnect, give us hand signals when clear. Thanks for the help.
Roger, and have a good flight.
Everything had been done that could be done to make this day a success. But in spite of his jovial backslapping, Alan Mulally would not be happy until his plane had taken off and landed successfully. The weather was one concern. There were strong winds and low clouds out over the Pacific, the route they were planning to fly.
We were almost to the limit on the tailwind for starting the engine. But these engines are just performing better than everybody expected. So usually we'd have to turn the airplane around, have the engine blow into it. And Kenny and John said, no problem. It started right up. Yeah, had a good start, real good start.
Airliner X-ray, Alpha Goose on 30. 1, 2, 3.
something? Oh, shoot.
I didn't want to miss any part of that moment because at the end of the day and the end of your life, you only go around once, and we all dedicated our lives to make the best airplane in the world, and to see that come together, I want to make sure that I didn't fully appreciate that accomplishment.
Did you think it was pretty? Yeah, let's get the order book out.
The flight was due to last 3 hours. While Cashman and his co-pilot, Ken Higgins, headed west over the Pacific, VIPs, 777 team members, and journalists waited on the ground.
And we're expecting our first in-flight briefing coming up in just a few minutes. Team Field, Mike Coughlin, Como News.
At least, we've been running integration tests.
1000億円以上を負担するなど、民間機の開発では最大のプロジェクトと言われています。
For those who may be interested in hearing about the status of the flight, let me just introduce to you Captain Jim McRoberts. He is our chief pilot for flight test.
The first flight took place before the eyes and ears of the world's press in what was one of Boeing's biggest PR operations to date.
Speed limit. You can see there under the operations column, he evaluated the handling qualities, and he did pulses, which are little wiggles of the wheel.
The pilot's radio messages were relayed to the press conference, although they could be instantly cut off if any problem arose.
Okay, copied about half of that. It gets fairly warm in the cockpit. Okay. So we really accelerated, got the gear up. But everything looks normal here, but I'm not looking at tack temps right now.
They're doing things today that you would normally never do on a first flight, like cycle a gear a lot, shut down an engine and relight it, and do all this extensive series of stall tests, with all these flap settings, and they've cycled all the flight control systems. And sometimes you can be very cautious on a first flight, leave the gear down, do a slow speed flight just to check what your landing speed is going to be, and then come back. But today they're spending 3 hours doing virtually what you would do if you were well into the test program.
That's right.
In fact, things went so well that it was 3.5 hours before the plane headed back to Seattle.
Feet and ring.
Okay, that one's complete. Okay, now get the whole wing, including the engine. We'll take it from about here. Okay. Thanks.
You found it. Oh, yeah. All right.
They're going to taxi in and park right over here on the Boeing ramp. They'll be greeted by Frank Schranz. Presents. Presents? They just got to fly for 3 hours. There they are. There they are out there.
Yes, I think it's because the back one's behind. Makes it look that way. Yeah. Oh, look how stable it is. It's a normal day of flight test. Oh my gosh.
Harm, most productive day of flight test ever.
You too.
On the most important day of his professional life, Alan Mullally still found time to marshal the press.
We want to get everybody kind of out of the way so that the media can get as good a shot as we can, okay? And here's what we're going to do. Frank and Phil and I are going to go out to the, Ron are going to go out to the bottom. Frank's going to say hello. And then we're going to have their families come out and meet them at the bottom so you can get that too. Then I'll bring them over here, okay? I'll bring them right to here, and then you can ask all the questions, okay? Okay? Okay. Am I a team player or what? Yes. Okay.
If we where you been?
Now,
put that. We don't need to do that. There we go.
How do they get it down? Careful, Frank. Okay, stay back.
Congratulations. Great job. Kenny, that's great. Terrific. Happy day, and you really made it for all of us.
Congratulations, Barry. Congratulations.
Fantastic. What a day, huh? Kenny?
Mark,
Mark, have you done any more? Good job.
There's some people are glad to see you.
You did a good job or what? Isn't that great? Great job.
Really fantastic. We were commenting to Frank that we've flown production airplanes that have been made for several years that are not as good shape as this airplane. I'm really pleased, you know, none at all.
What was the highlight?
The landing.
In the weeks after the first flight of the 777, there were several more first flights for the next few planes to come off the assembly line.
But when you see the data starting to come out and it's always falling on the good side, that's really encouraging. And it handles very nicely. Engines have been outstanding, really have. I don't worry about the engines at all. We've done a number of tests with engines shut down. I mean, even from first flight, we had enough confidence on that test to shut the engine down the first time. We've flown, I believe, 6 hours and 50 minutes now with one engine shut down, continuous, and then climb back to altitude and shut it down again for another 3 hours. So from that standpoint, I think the flying test bed and the conditions that we exposed it to there, the high altitude chamber at the Arnold Engineering and Development Center, all of that work that went into it has really paid off.
But in spite of Cashman's cheerfulness, things hadn't gone entirely according to plan. Whenever the nose landing gear doors closed at speed, there was a violent buffeting. This malfunction appeared during the first flight and was an actual design problem rather than a fault with that particular aircraft, because the same problem occurred as the second and third planes took their first flights. The team set to work on a solution. They eventually constructed metal plates called baffles in the nose gear well to disrupt the airflow. The problem disappeared. Then a new problem occurred. On an early test flight, a skin panel came off and sliced into the hydraulic lines that moved the landing gear. They'd already had a problem with locking the landing gear. This made it worse.
The failure occurred when the gear was starting to come up. And it was the process of the landing gear coming up at high speed that led to a vibration that caused this door to come loose, and in flopping around, it cut a hydraulic line. After that occurred, we knew that the landing gear would probably not lock into place, and we knew already how to make it lock. So I did this little maneuver rolling the airplane a little bit, and the gear popped in, and it was fine.
The Seattle newspapers, with their close interest in Boeing, were quick to report the event. It was the latest in a series of news stories that had highlighted problems the plane had had during testing.
And I'm sure for the press, it's hard to understand that failures of any kind are acceptable. Yet, to us, at this stage of the game, that's success. When people take that information and blow it out of proportion or misinterpret it or try to make a creative, dramatic story out of it, I get frustrated because it's not, I view it as somewhat of an attack on the pilot community, but also it's sort of a break in the trust that I think should exist in both directions. At the same time, I understand that it's a different world to most people. They relate to what these things would mean in the airline world with them flying as a passenger, and it's a totally different environment. We're looking for different things, and the goal is to solve the problems before we ever get to the airline world.
But the biggest problem was the plane's electronics. From the start, the 777 was designed to be flown by an entirely computerized system of electronic controls that would guide the plane's movements.
Pretty wild ride there for a little bit.
But there was also a whole range of other electronics in the plane, also run by computers, as people vied with each other to think up new things for the plane systems to do. It even took Boeing by surprise.
The first time that I remember being in conversations about it was associated with this managing information. And I can remember wondering what they were talking about. And, senior leaders of the airlines were telling us about, well, maybe we should have all of the maintenance information about an airplane on the airplane, because the airplane goes around the world and it stops at remote locations. So rather than to try to get the airplane back to the maintenance base, why don't you just take the maintenance manual with the airplane and all of the records with it and how you repair it and the repair manual. And then the entertainment side started to reveal itself to the airlines. And I think it all happened as a part of the evolution of digital technology in the entertainment business, and CD-ROMs and PCs at home, and all of us managing this more functionality and more capability, and because it can be done.
Fly-by-wire electronic controls were not new. Airbus pioneered the system in their newest planes, but the 777 would use new methods of data transfer and more computing power. Boeing built an entirely new laboratory to test and run the computer systems on the ground to ensure that the safety of the plane was not jeopardized by the technology. They sought to minimize the consequences of computer failure by having as many as 9 computers in situations where one would do. And because they were stepping cautiously into a new era, they gave the pilot the last word on many of the control decisions. But the task was unprecedented.
We have had to create in one small package, namely an airplane, a very large amount of computer instructions. The way we measure these is by what we call lines of computer code. Think of those as a sentence to a computer. This airplane has over 2 million lines of such sentences, which are created uniquely for this airplane. Other comparable systems, like the air traffic system that's being redone for the United States, that's 1.6 million lines of code. A modern military fighter has about 1.5 million lines of computer code in it for its flight systems and its fire control systems. I know that a submarine warfare aircraft that has all kinds of radar systems, and it's about 1.5 million lines. So in that regard, the 777 was a very substantial undertaking in terms of the amount of new computer programs and lines of instructions that had to be done.
The 777 was a plane whose computing power was dominated by the electronic services that the airlines wanted for their passengers. But the passenger entertainment system computers were many months behind schedule, even though subcontractors in the US and Britain were working overtime to find the bugs. No one had really understood at the beginning of the project how much computing power the system would consume.
The kinds of systems that BA and United will be flying, their entertainment systems, there's actually more computer code for the passenger entertainment than there is for doing the original job of the aircraft, which is carrying people from point to point.
The passenger entertainment systems had their own dedicated laboratory where there was a full mock-up of the 777 cabin. The plane would have a multi-channel video screen, a telephone, and a computer in every seat. To some, it seemed like a lot of effort to provide something many passengers wouldn't even want or need. Even Alan Mullally didn't see himself as ever using all the electronics.
I've always loved sleeping on airplanes, but maybe that's a problem I have. I like to sleep when I can get a chance to sleep. I love reading books. And the other day I was on an airplane and it was a pretty long flight, and I woke up having had a wonderful time on this flight, and I noticed that my colleague was still awake and looked like he'd been awake for a long time, and I asked him how his flight went, and he thought it was great. He'd watched 3 movies, he'd played interactive bridge, played some checkers, bought some things for his wife on the home shopping channel, was going to pick it up at the airport, and he thought he had a great time. I was glad I was me, and I was glad he was he.
Or even him.
Or him, yeah.
As the rest of the plane and its systems followed a schedule that took them nearer to the delivery date, the plane's computers just got further and further behind. United wanted to show off the plane at its best from the moment it went into service, so United's Gordon McKenzie grew increasingly worried.
I'd say the trickiest part of it is when we start getting into some real agony over some of our suppliers. We're trying to work the supplier issue, our buyer-furnished equipment, which is people supplying equipment on United's contract that they then turn over to Boeing, trying to get Boeing to work with us and the supplier to do a 3-way successful completion of the job. That's been very, very interesting. Still a real development struggle to get all that stuff put together and delivered on time.
That struggle would continue to worry United. Only a concentrated period of testing would show whether the team had built the systems correctly and gotten rid of all the bugs. The first 5 planes to come off the assembly line were being used as test aircraft, although 4 of them would later be refurbished and handed over to the airlines when the tests were completed. The first plane that would fly in scheduled service was given the number WA6, the 6th to come off the production line. While all the attention had been focused on the test planes, WA6 was moving through the factory toward its delivery date. It was the first of 34 planes ordered by United, which also had an option on 34 more. At every stage, United's representatives roamed through the factory, inspecting the results and highlighting any problems. When contracts were signed, Boeing had guaranteed to United that the plane would not exceed a maximum agreed-upon weight. By test weighing an unfinished plane, Boeing had some idea of how well they were doing, but the only test that would satisfy United was weighing an actual finished plane. This event was the culmination of years of design work, all aimed at making good on the guarantee to United. Airlines want lighter planes because they can carry more passengers for the same amount of fuel per flight. But getting the total weight right by calculating the weights of more than 3 million individual parts is hardly an exact science.
Normally, depending on the model of airplane, the variation from model to model that theoretically are identical can be as much as 1/4 to 1/3 of a percent. You'd say, well, gee, how can that be? Well, it just is. I mean, there's if you think about it, there's 100,000 parts that come together or so to make up an airplane, and every one of those parts has a little bit of variation in them. or my ability or our ability to understand what's in that airplane as the airplane's rolling down the line. And so we found that there can be that much variation in that, just from model to model to model. That's why we're very interested in understanding it. If you will, it's a measure of our capability here at the Boeing Company to produce airplanes.
They added together readings from several weighing pads, but this was like trying to weigh a person on two different scales at once.
This is the nose wheel of the airplane, and then scale A and scale B is where the two main gears will be sitting.
297,464, 297,462, and 297,467.
Right, so we're 36 pounds
36
off.
pounds off. You and I stay, we get to go.
That's the right way. What would Mullally be doing about now?
Oh, he would be jumping up and down. Trust me, I'll call it.
Doesn't get any better than this. I'm ecstatic. This is great. Yeah. This is what we're waiting for.
This is as happy as Gordon.
It doesn't get any happier than this.
One of the most important systems for passenger comfort, the heating and air conditioning system, was being tested in a plane set aside for that purpose. It was put through its paces in a range of situations representing the extremes of temperature it was likely to experience during service. Sharon MacDonald Schramm was the environment control engineer. Being both British and female, she was an elite member of two minorities at Boeing. For her, it was no problem.
Really, I think some people are just naturally bossy, which I think I am, quite honestly. And I think that's one common thread. Most of the women engineers here, I think we do tend to be more forceful. And whether it's because we're here because we are more forceful or we're more forceful because we're here, I'm really not sure. But because of that, we very often take the lead roles, and you know, it doesn't seem to be a problem at all. Being English actually does have some advantages, because everyone tells me it makes us sound more intelligent.
All the air used in the plane, hot or cold, would be taken from the engine and then spread through the plane to do a whole range of different jobs.
Depending on what you want to do with that air, if I want to melt ice on the engine cowl, I would stay right there at the engine and go to the cowl of the engine and melt any ice which might have formed if we're in icing conditions. As far as the air coming actually into the cabin, we would come from the air supply system in through the air conditioning pack. We would come through a whole series of ducting, and then we have air supply grills, which are above head height. The air would come out of the air supply grills, and the way our flow pattern works is that it goes across into the middle of the cabin and then circles back round, and we have a return air grill which is on the wall at about foot height, so the air circulation comes back round. We have fans drawing the air through, which helps the uniformity of the heat, and then depending on whether this is some air that's going to be recirculated, we'd go through a filter, we have recirculation fans, and then eventually the air gets exhausted out. We have outflow valves which let the air leave the airplane.
To investigate airflow, the engineers puffed smoke into the inlets.
We use smoke generators all the time. I mean, we should be 50 a day people at the rate we go. We use theatrical smoke generators primarily to watch the airflow patterns, and that's very successful. The bad thing is, sometimes we actually have to use tobacco smoke, and that's very unpleasant, and we all go home smelling quite disgusting.
At the peak of summer, the team flew south to Phoenix, Arizona, to test the plane's cooling systems.
We're down here to do hot day testing, and literally until you get here with 107-degree temperatures, we're not quite sure what kind of temperatures we're going to see. We did see some temperatures on some of our ducting that was a little higher than we'd expected, but we managed to take care of that and carry on testing. We do a whole series of tests which are really for Boeing's benefit, to make sure that we've designed things correctly and everything works per the design. The certification tests that we do are for the FAA to make sure that the plane is fully safe to fly. So yesterday was our first cert test, and we passed with flying colours, so we're very happy about that.
For the first 4 years of the 777 project, the 10,000-strong workforce had been led by Alan Mullally. More than anyone else, he had typified the open spirit of a new management philosophy, which made it all right for everyone to bring their problems out into the open, solving them as a team rather than keeping them a secret.
I think the human spirit is a fabulous thing. And I think there are beautiful butterflies in all of us. And I think that we come with no baggage and no burdens and no limitations in our own minds. And I think the environment we're trying to create is that we'd have a shared thought, a shared vision, a shared appreciation, a shared understanding of what it is we're really going to try to accomplish together.
Now, Mullally had been offered a promotion that would take him away from the 777 project.
He came in here one day in my office and said, Ron, this is what's being considered. He said, and asked me what I thought. And I was in shock. I said, what?
He said, you're kidding. And I said, I'm not. He said, you're kidding. And I said, nope, I'm not. And then we both looked at each other for a while, and then we said, it'll be okay. We'll figure out how to make it okay.
It just didn't seem like the right time from a company point of view to pull the leader out and put him elsewhere. Now, the job that Alan has taken on, in my opinion at the time, didn't seem to rationalize taking him from this program, because we just felt we needed that leadership. But it was kind of a shock thing, really, at the time, and my advice, and he asked for it, was, Alan, I don't think this is right, and I don't think you should do this.
Something I feel really good about is that we talked about that way before it ever happened, and not just me, but all of the members of our team, because life's about change, and life's about being adaptable, and so we tried not to make it a bigger deal than it really is.
Mullally's successor would be Dale Hogarty, who had been in charge of the manufacture of the plane. A quiet man from the American West, he had none of Mullally's natural charisma. Still, he had proven himself through the many months of manufacturing the plane.
I'd be less than honest if I didn't tell you that there was a little fear and trepidation with that, but a lot of elation too. It's a unique experience to think about, having been with this program from the outset and then get to be the boss. You know, I don't think that happens very often, and that was really a marvelous feeling for me.
As Mullally left the project, it almost seemed as if the worst of it was over. But ahead lay a series of critical tests that would determine how well the plane performed in the most extreme situations. The next tests took place at Edwards Air Force Base, about 100 miles from Los Angeles. It has a 15,000-foot runway, one of the longest in the world, with plenty of space for the more dangerous tests that the team was about to carry out. The first was called VMU.
VMU stands for Velocity Minimum Unstick. And basically, it's a demonstration of the minimum speed that the airplane can lift off at. And it's achieved by putting the tail on the ground, and that's basically the highest angle that the wing can make with the air on the ground. And it's to show, actually, that the airplane will fly. Very early jet transport, swept-wing jets, had a problem that you could do that and never get off. And there were several accidents in early jet history that this was an outgrowth of.
To make the most of stable weather conditions, these tests were scheduled to begin at dawn. To get the plane ready and complete the pre-flight checks, the test crew and pilots arrived at 4 a.m. The VMU test would help to define a safe minimum takeoff speed for future pilots. The wing generated the most lift at the sharpest angle to the ground, and the test would show how slow the plane could travel and still lift off. It would also help in a situation where a pilot had to take off suddenly at a sharper angle than planned to avoid an obstruction, for example. During a dozen or more VMUs at a range of speeds and weights, the team gathered the data they needed. The base of the fuselage was protected from damage by a block of oak, replaced every few takeoffs as it wore away.
Gross weight, 41%.
The next important series of tests was designed to see how well the plane braked on dry and wet runways.
I guess this is where, Porter, you said you didn't want to jump right back into wet ones. You want to do a couple of dry ones first and then do the wet landings?
Because the Southern California weather was so hot, water would evaporate, so the runway would be sprayed with a special liquid. John Cashman hadn't known about this and was concerned.
Is there any chemical in the water you're spraying? Is it wetting?
Yeah, we have a protein. What it is animal blood and fats and stuff like that, but it's no harm, and especially with the dilution that we'll have.
But I wasn't worried about harm. But does it totally evaporate?
Over a period of time.
What I'm wondering, guys, let's just do this one time.
I'm just wondering.
That's the thing, I don't think that stuff's going to leave the runway. It may not leave it for a day.
That's what I just wonder if it has the animal proteins in it.
Yeah. You have to wait till the coyotes get out.
440 dry RTO might be some good data.
What's going to be the procedure with a hot break or a break fire or something like that?
Are you the outside ground ups?
I'm it.
Okay. The only guy should be talking would be you.
Okay.
If we have a fire, we come to a stop, and it's more than a grease fire, or it's enough of a grease fire that we need to shoot it.
We have been accustomed to carbon fiber causing some flaring and maybe oil residue or something. We don't get excited, but we don't take no action unless your designee says so.
If it's really bad, I mean, we'll call, but unless otherwise advised, we'll go out the front. If for some reason we don't want to blow a door out the side, the next best way, I think, is out the cockpit, using the escape rope out the cockpit. Then you're somewhat shielded by the forward fuselage. And when you get to the ground, you run like hell forward, down the center line of the airplane. You don't look around to see what's going on, or you may get trampled by the pilots.
It sounds like manure, doesn't it?
No problem.
You may be alone on the airplane.
No problem.
No problem.
The liquid was sprayed on the runway in a wide band to provide a suitable landing target for the plane. After checking the slipperiness of the liquid, the engineers left the runway so the tests could begin. Although the plane looked as if it was landing squarely in the middle of the wet patch, Cashman felt that something had gone wrong.
The airplane went into the wetted area and it started to slide. And I tried to steer it back, but it was so slippery the nose gear didn't really bring me back. The nose gear didn't have any bite into to provide a steering change. So I had to use the rudder, the aerodynamic controls. And when I did that, when that happens, that also causes the airplane to move sideways. And so I put a little bit in and I got it aimed back the other way. And then I put another correction in and I'd hoped that wouldn't go out the other side. And I didn't, and I managed to get it back on the center. But my feeling was we had gone off with the left wheels slightly into the, at least not totally wet area. And the data seems to indicate that might have been the case.
The load on the brakes was changed before every test flight by adding or removing ballast. Cashman noted some key information in a place where he was sure he wouldn't lose it.
I put two numbers on it. The top number is the number of people on board. So in emergency, you can notify a crash truck how many people are on board. This other number is what we call the zero fuel weight. That's basically the empty weight of the airplane with the people on board. It's 382.5 in this case. So that number plus the fuel is the total weight of the airplane.
Test followed test as the team alternated takeoffs and landings in escalating degrees of wetness. The plane had also been put through a series of spray tests that checked the effect of larger amounts of water on the engines and control surfaces. If water stayed in some of the crevices, it could freeze and jam the controls. Finally, the team met to prepare for the last and most dangerous test, the one they called the big one. It would be the first time the plane had used its carbon fiber brakes at maximum weight while going at maximum speed with maximum engine thrust. But the day before the test, John Cashman was worried. He had just heard that the test had to be done at a higher thrust rating, 88,000 pounds instead of 84.
I'll tell you my concern. We'll talk about brakes here in a second, but we've done all this buildup at 84, which has given us the confidence that you guys can predict the distance to excel to, the cut speed. Now we're changing to another level on an engine that's never been run above 84. Other engines have been run above 84, but these have not. Plus, we have an engine that's had 10 fuel cuts on it. And partway through this acceleration, I don't want to find out I have an engine problem. Because for whatever, I don't know how that got transferred, but we may have to fly in this at this condition. If something happens, we blow a tire before cut speed, we're flying. So we need an engine and a rating that will fly in the air. So that's where I'm concerned, is we've done all this buildup, which builds confidence and gives you guys validation that you have a pretty good estimate. And now we're changing to a level that we don't know really anything about, or even if these engines will do it.
The test plane had engines and brakes ordered by United Airlines. What troubled Cashman was the fact that a change had been made at the last minute to satisfy a guarantee made to British Airways, whose planes would have different engines and brakes.
Why do we have to do this at all if it's not BA's brake?
I'll tell you what I've heard. What I've heard is that there was a contract entered into with the brake vendors, and Gray has not heard this same story, but that we were going to only produce one flight manual, so we'd only have one level of performance.
So why do we just find this out on the day before we're going to do this test?
Don't know the answer to that one.
Yeah.
Because all this buildup should have been done at this engine rating.
Well, the story I heard is needs more energy for the GE engine.
Yeah, but this isn't right now going to be on that airplane where the concern is. It may be on somebody else's, but.
Right.
To be honest with you, my worries are not what happens after I stop. If everything blows up at 3 knots, I don't care. I mean, I care, but what I worry about is something happened before I stop and I go off the end. If we're running on rims at that point, we may collapse the gear, and it would be pretty ugly.
These guys, and I lump you all into one category, it was your collective bosses that started this whole thing. You don't seem to be particularly comfortable with it. Why don't you go, we can still have our pre-flight. This doesn't affect the pre-flight. The pre-flight works the same either way. Why don't you go consult with your bosses and come back to us sometime this afternoon with a recommendation?
Very good.
In the meantime, we'll change the engine and we'll be ready and we can go either way.
Yeah, that's right. But I still may not do it.
I said recommendation.
The team needed to determine whether the test would require an unacceptable risk. First, they ran the engine to see how it performed at the higher thrust, and then they checked with the brake manufacturers to see if they had tested their brakes in the laboratory to the higher braking force. When these results were reported back to Cashman, he decided to go ahead with the test in spite of his reservations.
Okay, very good. Any other comments? Very good. Okay, we'll tackle it tomorrow. Everybody sacrifice and...
You too, Jerry. Except the pilots. Sacrifice
except for the crew.
Sacrificing was a Boeing tradition on the night before a really important test.
There's somewhat of a tradition that among the flight test personnel that if people don't go out and have quite a bit to drink the night before, the winds will not be favorable. And sometimes it actually seems to work, so anything that works on the winds, we're willing to accept.
This way, falling over, full bore this way.
This counts here.
The flight test team liked nothing better than to relax with a beer, a hamburger, and videos of plane crashes from the past.
Whoa, nice landing. Oh. That's by far.
Like the rest of the 777 workforce, the flight test team had taken to the working together philosophy. It had been a revelation for one British engineer on the brakes team.
It's worked very well with the supplier because I think that that traditionally is an area where things can get adversarial if you're not careful. And the supplier I worked with have worked with Boeing for a long time, and you develop a rut where you sort of tend to get very contractual if things aren't going exactly the way everybody wants. And we were able, with some difficulty at first, it took quite a few months to really learn to trust each other, to get away from that contractual way of doing business, and to really start to see the other person's point of view, and to start to help each other. And it really got better and better as the program's gone on. And now I think we have a really fantastic relationship. We trust each other, we enjoy working together, and the dividing line between Boeing and the supplier is sort of, it's not very visible, it's sort of merged. We're just working together as a big team, getting this project done. It's worked wonderfully well for us, it really has.
The following morning in the cool dawn, the 777 set off for the big one. Rarely had a plane been put through the ordeal that this plane was about to experience.
All stations, 777-1's made its third stop at 06-16-12 at 3.17 miles. And we'll be taking the runway and holding short. Car 1 copies.
The test would have to demonstrate not only that the plane could stop before the end of the runway at maximum speed and thrust, but that it could also withstand the tremendous heat that would be generated in the brakes without catching fire. This test had been designed to reproduce the situation that faces a pilot when he has to brake with maximum force due to engine failure or an obstacle on the runway. The plane was at the maximum weight it would ever carry, laden with ballast to take it up to 288 tons. Cashman would accelerate the plane to a speed of 210 miles per hour and then apply the brakes with maximum force. Just to make the test even harsher, the brakes had been worn down to the minimum allowable thickness.
1, 2, 3.
Halfway down the 15,000-foot runway, Cashman slammed on the brakes. As the plane traveled another 4,000 feet, the carbon discs and pads heated up to 3,000 degrees centigrade. The team had to demonstrate was that after braking, the plane could stand or taxi for 5 minutes without catching fire. That was the estimated time it would take fire engines to reach the plane. During that time, Cashman and his crew would be sitting on a potential time bomb. As the plane taxied carefully back to the stand, several fire engines waited, counting the seconds until they could put out the flaming brakes and cool the wheels. Each tire had a fuse plug which melted at a certain temperature. Before the tires became so hot they exploded. All 12 wheels were destroyed at a cost of $750,000. But the plane didn't catch fire, and the brakes performed even better than expected. The test had put 9.7 million foot-pounds of energy into the brakes and shown that the plane could survive, almost intact. With the hardest test of strength behind it, the main challenge still facing the 777 was the testing of its endurance. Boeing had promised that the 777 would be the most reliable plane ever to go into service. Over the course of the next 7 months, they would be called upon to prove it.
In 1941, Orson Welles made a powerful, unforgiving film portraying newspaper magnate William Randolph Hearst. In doing so, he made a powerful and unforgiving enemy. The American Experience presents the battle over Citizen Kane. Then stay tuned for the Oscar-winning movie itself, Citizen Kane. It's all coming up next here on KSBS, your public TV for information and entertainment.